So in a previous video, we talked about how to find the distance between 2 points using the Pythagorean theorem. And what we did in that video was we drew a line between our 2 points that created a diagonal. And then we used the Pythagorean theorem by drawing a right triangle. So for example, if I wanted to find the distance between point P and point Q, I would draw a diagonal and say, well, I want to know how far apart those 2 points are. And the way that I would find them is I would draw a right triangle. So I would draw this leg PR, and I would draw this leg QR, and I would find the measure of PR, the measure of QR, and then do a squared plus b squared to find this missing leg c squared, the thing that I want to know. And I said in that video that I would later show you something called the distance formula, which was a way that you could find the length of a segment between 2 points on a coordinate plane without drawing a picture. And that's what I'm going to show you here is how to use this thing called the distance formula. But before I tell you what the distance formula is, I want to show you where the distance formula comes from. And it comes from the Pythagorean theorem. So I'm going to find this hypotenuse of this triangle, and I'm going to do it without actually writing any numbers down. I'm not going to use any coordinates here. I'm still going to do the Pythagorean theorem, but I'm going to use these labels here, which are just x1, x2, y1, y2, meaning it's some x and y coordinate. It doesn't matter what the x's and y's are. I'm just calling them x1 and x2 just to show that they are different x coordinates. So x1 is, this is some x coordinate, and x2 is a different x coordinate. So if I wanted to know this length right here from P to R, how long is that? Well, the way I would figure it out if I knew what the numbers were, if I knew the numbers of the coordinates and I wanted to know how long that was, is I would take whatever this x2 is, whatever number that was, and I would subtract whatever the x1 is. So, for example, if the x2 coordinate, and I can literally figure it out, 3, 4, 5, 6, 7, this is 7, and the x1 coordinate here is 2, I could just do 7 minus 2 and say, oh, okay, the distance there is 5. But I said I was going to do this out numbers. What I'm really doing is I'm doing whatever the x2 is and subtracting whatever the x1 is. That's how I'm going to figure out what that distance is there. And so to figure out the distance between the y's, meaning the distance from R up to Q, I would do the same thing with the y coordinates. I would take whatever the second y coordinate is, that y2, and I would subtract whatever the first y coordinate is, that y1 right there. And that's how I'd figure out what that length is. So the length of the bottom is x2 minus x1, and the length of the other side is y2 minus y1. Okay. And then my question mark here, the thing that I want to know, is going to be, I'm going to call that D, because the thing that I want to know is what is the distance between those 2 points. And now, even though it looks kind of weird because I'm using all these variables instead of numbers, I'm going to do the Pythagorean theorem. So this part at the bottom, I'm going to call my A, and this part on the side, I'm going to call my B, and then this part over here, of course, is going to be the C. And the Pythagorean theorem is a squared plus b squared equals c squared. So I'm going to do a squared plus b, let's make our colors make a little more sense here. B squared equals, and then d is what I'm using for distance, so that'll be that, c squared, just like that. So this is what it looks like when I plug those things into the Pythagorean theorem. A squared plus b squared equals c squared. This does not tell me what the distance is. It tells me what the distance squared is. So then the last thing I would do to figure out the distance is square root both sides of this equation. So the square root of d squared is pretty simple. If you have the square root of something squared, it's just that thing. So the square root of d squared is d. And then on the left side, I have the square root of that big, huge, nasty thing. Now, you might be tempted to say, oh, well, that also just cancels out the squareds. It's not quite that simple, I'm sorry to say, because of this plus sign right here. That plus sign really complicates things and makes it to where I can't just cancel out the squared. So I'm sorry to say that I'm going to have to leave this side of the equation as x2 minus x1 squared plus y2 minus y1 squared. And this right here is the distance formula. So in your notes, you should write that down and highlight it for sure. Maybe put some arrows pointing at this formula for sure. Label it the distance formula. The distance formula. Put some stars around it maybe. Put some stickers next to it. Put some glitter on it if you've got glitter. This is an important formula, the distance formula, because even though this distance formula looks kind of gross, this formula right here can be, number one, it can 100% be put into the calculator. So the calculator can do all of the mathematics for us. And number two, if we're ever asked to find the distance between 2 points, this formula right here can do the entire thing without us ever having to draw a graph and use the Pythagorean theorem to find that distance. Let me show you what I mean. Let's come over here and let's say I'm asked to find the distance between the points, and let's say 3, -7, and 15, 12. Okay, I'm going to find the distance between those points. So all I have to do to find the distance between these points is to label which one's going to be x1, y1, and which one's going to be x2, y2. Just label which is which, and then substitute those into the distance formula. So let's call this one x1 and y1, and we're calling those x1 and y1 just because those came first in the problem. There's really no better reason than that. Let's call these x2 and y2 because those came second in the problem. And so now we're going to use our distance formula. We're going to write the distance formula exactly as we have it, except everywhere we have, and I'm going to write the distance formula just everything except the x2s and y2s. And x1s and y1s. I'm going to write the distance formula blank except for those, and then I'm just going to go through and substitute where the x1s, y1s, and x2s, y2s go. So the x1 was 3, so I'm going to put that in the distance formula where x1 goes. And the y1 was -7, so let's put that right there, -7. So the x1 and y1 have been substituted into the formula where they go. And then I'm going to do the same thing with the x2 and y2. So the x2 was 15. There's its spot in the distance formula. And the y2 is 12. There's its spot in the distance formula. I can put this in the calculator exactly like that, and the calculator will give me the correct answer. Now, it makes me a little antsy to put minus a negative in. That just really bugs me because I know minus and negative is the same thing as plus. So before I put it in the calculator, I really feel the need to clean that up. Most calculators are fine with you putting minus negative in there. I just don't like it. But you can put this entire thing in the calculator just like that. If you're a little worried about your calculator skills, though, there's no reason you can't keep going and simplify it even more. 15 minus 3 is going to give us 12. And 12 plus 7 is going to give us 19. So we could put 12 squared plus 19 squared. We're just simplifying what we're going to put into the calculator. We could keep going even farther than that, but I feel reasonably confident I can put that in the calculator without making any mistakes. So let's try it. Let's do square root of, and then I need to make sure this entire thing makes it into the parentheses. So 12 squared, you'll notice I've got parentheses there, plus 19 squared. I'm going to close the parentheses. Notice the 12 squared plus 19 squared, the whole thing in parentheses means the whole thing is going to be inside of the square root. If you are doing this on a TI-84, which I recommend, just make sure the line on the square root goes across the entire 12 squared plus 19 squared and not over just the 12 squared. Make sure the entire thing's inside the square root, and you should get 22.47. So we're going to say the distance between these 2 points, oh, I don't want to do equals. I'm going to do approximately equal, so that wavy equal sign, approximately 22.47. And so there's our distance. It's about 22.47, and that's how we can find the distance between those 2 points without using a graph or the Pythagorean theorem, and it's using this distance formula, which if you have access to a standard formula chart, the distance formula is on there, so there's not really a reason to memorize the distance formula, but after you use it a few times, you probably will have it memorized anyway. It's not a super difficult formula after you use it a few times, and it is very, very useful for quite a few things, not just finding distance, believe it or not. We're going to use it for a few other things besides distance, and I think you'll be surprised at some of the uses besides just finding distance between 2 points.